Good afternoon, everyone. Today we will be trying to solve this problem in Google in Scratch. So this problem is basically we will have a robot and we want to make it go through the entire maze. First, there should be a remix button here, but because I created it, there is none. So what we're going to do is we're going to file and save as copy. Okay. So now that this is a copy, well, I'm going to teach you a few about all the Scratch buttons. First, let's learn about move 10 steps. So when you make the robot move 10 steps, it will literally move 10 steps. As you can see, no 10 steps, 10 steps. Now we're going to learn about moving 15 degrees. So when you make it robot move 15 degrees, it will keep turning, right? So let's counteract the problem that every time we run this program, it will start at a new degree. So let's always make it point at 90 degrees. That way, every time we press click, it will point at 90 degrees. Okay, so now that we learned about 15 degrees, now it turned 15 degrees. Now let's try 90 degrees. Oh wait, sorry. Let's quickly do that. So basically now this will turn 90 degrees. If we want to make it turn 180 degrees, basically turn around from this to, when you do this, it flips around. Basically, if you're confused with this, please feel free to use this on the side to clarify on your confusion. Okay, so basically 90 degrees looks like this. Basically, it will turn it 90 degrees. 180, basically, you can think about it flipping the robot, and negative 90 is flipping it the other way, while 0 is no movement at all. Okay, so now that we learned how to flip the robot, let's use these steps to solve the maze really quickly. Something I really recommend when using Scratch is using this. By just clicking it, it will do the action. So let's try solving this maze real quickly by just using the sidebar. Okay, so let's make it turn until now. Okay, now it's 0, and then we can make it move 10 steps, 10 steps, 10 steps. Oh, one more. Then now let's make it turn this way. So basically the robot will go that way. So 1, 2, 3, 4, 5, 6. Now let's make it go through a few steps. Now let's make it move the other way. And basically, I really recommend. Oh, it's not very good. I really recommend using this to help you understand what's going on. Right. So I'm just clicking through these buttons and making sure that I understand. Oh, you see, I messed up. So you're going to need a little bit more precise, but I hope that clears it up. So now let's actually try to program it. So first, we would want to turn this, oh, no, the other way, sorry, this way, 90 degrees. That way the robot is facing that way. Then, like we learned, we're going to move 30 steps. See if that does it, and it quite does it. Now we want the robot to move this way. So we'll do this and turn this into 90. As you can see, now it will turn this way. Now keep doing this until you go through the right steps. After a while, you will get the hang of it and see what numbers are right and what you might be doing wrong. So I'll just do this real quickly and I'll come back. Okay, I quickly did all of this, basically just going through what we were doing. So let me just run it real quickly. So basically, we just follow the instructions and go through the maze step by step. So now that we finished looking at the motion, well, all the motions that are important, let's look at the events. So basically, these events are when flag is clicked, this is when the flag is clicked. When space is pressed, this is when the space key is pressed. All programs under here will be working, but this is not only for these things, it can be for any single key. Then when sprite is clicked, basically when you click the item. Then when backdrop switches to backdrop 1, this is when backdrop changes, when loudness is greater than that, but we won't be using that. So this will broadcast, let's just explain this simply. It's basically like sending a message to your entire program. When you broadcast dead, when you broadcast hello anywhere, you can always just say when received hello, then it will do an action. So that is broadcasting. Now let's look at controls. Wait 1 second is quite simple. You basically wait 1 second, repeat 10 times, or here where it's editable, you can change to how many times you want to repeat a specific action. Basically, if you want it to do this entire sequence of code again and again and again, you see it repeat 2 times, then we'll basically go through the entire program 2 times. After repeat, you can do forever. This basically will make the program run forever, never ending. If then, basically, if a specific thing happens, I'll explain this looking thing here later then. So basically, if I hit the button, then it will say good job. Then we have if then else. You can do this like if the robot hits the button, then good job, else. If it does not hit the button, then not very good job. After this, we have wait until. Basically, this won't really be needed, so I won't explain it. And repeat until, basically this will repeat an action. So basically, if I say repeat going forward until the button is hit, then it will keep going forward until the button is hit. Stop all basically stops everything in all your programs. Okay, we're not going to be using sense. Actually, no, we will be using sensing. So sensing is an important part of Scratch, and especially robotics. So basically, these things are basically the sensors of your robot. You know how you have the eyes, the mouth, the nose, the ears? These are the senses your robot has, well, at least in Scratch. So first, it will be if it's touching specific thing, if it's touching button, right? If it's touching the button, then, example, we can use these things here. If, let's use a quick Well, I won't run this because there is some program here that will interfere with it. But basically, you can use this if touching button 3, then it will do a specific action. Then we also have if touching color. Basically, this will be like, oh, touching color. This will be like, you could use this if it's touching the border of this color. So basically, this color right here, if it's touching this color, then go away. And then most of these won't really be used. So I just recommend using these for this map. Okay, operations. These are basically how you introduce math into your program. Basically, if you want to add repeat 1 times 2, so basically it will get the answer. What's 1 times 2? It's 2. So it will repeat 2 times. Then all these are basically plus, minus, multiplication, division. Pick random, basically we'll get a random number from 1 to 10. This could be like, you can always edit these numbers like 9, 5. Basically, this will pick a random number from like 1 to 10. This is when you want to add a random element to your program. This is very useful. Here is also one of the kind of senses. Like it will tell you true or false, just like all the senses. Remember, if it is touching this color, it can only be a true or false, right? So also these, if a specific number, if 5 is greater than 50, then it will do an action. But if not, that's why you have the then else. If 5 is greater than 50, then it will do a specific action. But if not, then it won't do anything. Then else, you can add something here. After that, you have the rest less than and then equal to. Here you have end. Basically, if you want to make it like, if it's touching this color, and it's also touching another color at the same time, right? If the robot's touching red and orange at the same time, then it will do a specific action that you ask it to. And after that, we also have the or, basically if it does either touching red or touching blue, if we use the variable or. Oh, sorry. If you use the variable or, you can make it be like touching red or touching blue. So basically, as long as it touches one of these colors, it's going to do a specific action. Then it's not basically, I don't recommend ever using this unless it's to simplify your code. This basically does from true to false, right? So if you do not touching red, just like the word implies. So if it is touching red, but not, if it is not touching red, so if it's touching blue or white or any color but red, then it will do the action. After this is variables, but I don't recommend variables. So using all this knowledge, I will show you a better solution for this, but I do want you guys to pause the video and use the knowledge I just taught you to try to think of your own other solution. So now I'd like to introduce you to new solutions. If you haven't left already to do your own solution, I really recommend it. So basically, one solution I'm thinking of, I always like to draw it on the board first. Basically what I want to do is make the robot going, like turning a random degree at a time, like random, and basically hitting all the walls and all the walls until it eventually finds the button. Because remember, the goal is to write this in the least amount of number of code lines. Basically hit this wall and then this wall and then basically like randomly turn and just see and go around the maze until it eventually finds this. So to do this, we're going to do forever because we want this to be forever, right? We want it to until it hits the button. But when it hits the button, it will already cause everything to stop. So this will be forever. It will forever be going. Now I want it to turn a random degree. Basically, let's find it. Turn. And we already learned random, right? Random from -90 to 90. Let's see how that would go. Basically, it goes randomly, but I don't want to waste my robot's time, as I already know that you don't need to move like into 11 degrees of rotation to get through this maze. I'd like to think about this maze as only a 90-degree rotation needed for this maze. So basically, what I'm going to do is I would want it either -90 or 90. And to do this, one solution I found, maybe there's other solutions, but basically I want to pick random from -1 to 1, right? So either pick -1, 0, which will do nothing, so we ignore that. So -1 or 1, that's all it will pick. Now if we add this, and then we multiply it by 90. So here, this program will basically pick a random number from -1 to 1. So here we can drag this in. Basically, this will turn either 90 degrees or not. So here you can see that this number, let's make it weight. That way we can see it a little bit better in action. So here you can see that it will turn a random degree every single second. Like, oh, now it's turning 180. So it'd always be a 90 thing. So 90, 180, -90, -180. There's no -180 now, is there? So either it will turn 90 degrees or -90. So now that we have this, the next part of the solution I want is basically, I want it to start moving, right? So let's make it move 3 steps, because I think that's a safe number of steps, 3 steps, right? Then after it picks a random degree, I want it to move 3 steps, not only 3 steps, but I want it to repeat until. So it will repeat moving 3 steps until, now here's what we use our sensors, right? Repeat until touching the border. Basically, we'll just use this button here to see the border color, and it will basically repeat moving 3 steps until it touches the border. So basically it'll go like this and then touch the border, and then it will turn 90. So let's see if this works. As you can see, now let's see what we did wrong, right? So basically what happens is it hits the wall, Oh, do you see what it does wrong? I always recommend to use the wait 1 second, right? Okay, I think this, okay, let's use something different, right? Instead of touching the color, let's use one of our other sensors. Now I want you to think about what sensor this could be. Okay, it is touching the sprite one being the maze, okay? So it will repeat this until it touches the maze. Now let's see if this works, okay? It stops, oh, and then it doesn't move because it immediately touches the thing again. It immediately touches the thing again because it's never moved away. So now what we want the robot to do is move away from the border. So let's go through this system. Basically here, it turns a random one from -90 to 90. Here it moves 3 steps until it touches this maze, until it touches the border of the maze, and then it moves away from the maze to protect itself. Okay, now let's try this out. Let's use a little less time because this will just slow us down. 3, 2, 1, go. So basically you can see that it is definitely random. If you run this 100 times, it will be random again and again and again, right? So it will take some time to finally reach the button, but it will eventually reach the button. Now, this is one solution I thought of, but you can always think of other solutions. Let's go through another solution I thought of if you still need more practice. So let's think about this maze in another direction, right? Why don't we just make the robot go like here, hit the wall, go up, here, hit the wall, go up, here, hit the wall, go up, here, hit the wall, go up. So basically it will eventually, because it's from the bottom to the top, it will eventually reach the top until it hits the button. So how might we come across solving this? Again, let's use forever, okay? Control forever, because we're going to want the robot to go up forever, right? And then what we want to do is repeat an action. Repeat an action touching sprite 1. Wait, 1 second. Okay, sorry, I mixed something up in my solution. Basically here, what we're going to do is we're going to make the robot go up, and then only when it hits a wall, it will turn. And then when it hits a wall here, it will go up and turn, up and turn. No, actually, because we want to make it up its main direction, because it'll just go faster instead of going like this. It will just go up. So it'll go up, hit an action border, go turn, then go away from the thing and go up, and then it will hit something here. So what it would want to do is basically go all the way here, and then up and then there. Anyways, let's go step by step. So it will repeat an action until touching sprite 1 again. So what action will this be? Oh, sorry. It will repeat changing y, changing the y by. So basically the y-axis is this. So if we run this, it will keep changing the y until it hits the border, right? Oh, sorry, not 10 because that's too many. So let's make it 3 again. So basically, no matter where you will put it, it'll change the y until it hits an item. Then we don't want it to stay there. We're going to make it go backwards. So change y by a -1. Change y by -1. Oh, 1. That way it goes back down and it's safe. Now after this, what do we want to do? We want it to repeat another action. It's already here. We want it to turn, right? Okay, so repeat an action until, again, touching sprite 1, touching another border. And now we want it to turn motion. We want it to move. How many steps? Let's just make it 1. So it will repeat moving 1 until there. So you can see it will keep going. Oh, but then what does it do? We've got to make it go away from the thing, because again, it will just stay there. So move away, -2. So let's up. Sorry, that's because it's not in the maze. Excuse me, little character. There. Oh. Let's make it just go here. Oh, I moved the maze. Oh, I'm deeply sorry for that. Okay. So now that I fixed the maze, basically we're coming into a problem. Now it does what it wants us, what we tell it to do. It goes forward until it hits a wall, and then after it goes left and right until it hits a wall, and then goes forward up until it hits a wall. But we need to make it go this way too, right? So here is where we add another element to this. I'm going to introduce variables, okay? Basically what we're going to do is add a new variable called direction. Direction, I think that's how you spell direction, I hope. Basically what this direction will do, it will either be 1 or -1, right? So set direction to 1, right? And then once we have a direction, we're going to need to change this, right? We're going to need to change it every time. So basically, we're going to need to make this the direction. But how do we make it change? Oh, also this one, because we're going to need to make it move away from the wall, right? So it's going to need to go the negative of the direction it's going at. So we're going to use a math and then multiply it by the negative of itself, right? So here, direction, oops, sorry. Here you've got a direction, then you just multiply it by -1. Once you have this, you would want to change, basically set direction to a new variable, basically, because it's right now, you can imagine that it's positive, right? Okay, let's leave it at 1. So you can imagine it's positive, so it's never going to do anything. There's no point. Sure, it works, but it will never change the other way. What we would want to do is make it change by multiplying itself by -1, just the way the steps did, right? So just like this one, we're going to copy this code, Control-C, Control-V, and put it here. So it's going to get itself and multiply it by -1. So basically it's going to flip itself around. It's going to go the other way around until it and then it's going to set itself to this new variable. So you can imagine, yeah. Now let's see if this works. Let's reset this and see if the robot goes the right way. And then as it should, it does. Now I hope this shows you how different problems can have many different solutions to it. And I know you guys can find a better solution than me. So if you guys have find another solution, please feel free to send it to me. And this is also very important to robotics because thinking out of the box is one of the most essential skills you'll need in robotics class. And I really hope this video helped you in a way if you were confused. And see you next week for robotics.